All stars form from the collapse of material in a giant molecular cloud. These clouds consist primarily of hydrogen, helium, and dust. Turbulence within these clouds causes knots to form, which can then collapse under its own gravitational attraction. As these knots collapse, the material at the center begins to heat up. This hot core is called a protostar and will eventually become a star. The cloud doesn't just collapse into just one large star, but different knots of material will each become its own protostar. As the protostar gains mass, its core gets hotter and more dense. At the temperature of about 10 million degrees Celsius or about 18 million degrees Fahrenheit, the protostar starts fusing hydrogen into helium, becoming a main sequence star. Stars which fuse hydrogen into helium are called main sequence stars. The main sequence phase is the longest phase of a star's life. The radiation and heat from the nuclear reactions keeps gravity from collapsing the star during this phase of the star's life. Lighter stars like our Sun will be in this phase for billions of years, while more massive stars may only be in this phase for millions of years. Eventually, the core of the star runs out of hydrogen, and when that happens, the star can no longer hold up against gravity. Its inner layers start to collapse, which squishes the core, increasing pressure and temperature. While the core collapses, the outer layers of the star expand outwards. The star expands to larger than it has ever been, a few hundred times bigger. At this point, the star is called a red giant. What happens next depends on the mass of the star. When medium-sized stars up to about 7 times the mass of the Sun reaches the red giant phase of their lives, the core will have enough heat and pressure to fuse helium into carbon, briefly stopping the core's collapse. Once the helium in the core is gone, the star will shed most of its mass, forming a cloud of material called a planetary nebula. The core of the star will cool and shrink, leaving behind a small hot ball called a white dwarf. A white dwarf doesn't collapse against gravity because of the pressure of electrons repelling each other in its core. Red giant stars with more than 7 times the mass of the Sun go through some of the same steps as the medium-sized stars. First, the outer layers swell, but at a larger scale, forming a red supergiant. Next, the core starts to shrink, becoming very hot and dense. Then, fusion of helium into carbon begins in the core. When the supply of helium runs out, the core will contract again, but since the core has more mass, it will become hot and dense enough to fuse carbon into neon. When the supply of carbon is used up, other fusion reactions occur until the core is filled with iron atoms. Up to this point, the fusion reactions put out energy, allowing the star to fight gravity. However, fusing iron produces less energy than the energy being put in. Therefore, with the core full of iron, the star will lose the fight against gravity. The repulsive force between the iron atoms overcomes the force of gravity, and the core recoils out from the heart of the star in an explosive shockwave. The shock propels material away from the star in a spectacular explosion called supernova. The fate of the leftover core depends on its mass. If the leftover core is about 1.4 to 5 times the mass of the Sun, it will collapse into a neutron star. If the core is larger, it will collapse into a black hole. To turn a star into a neutron star, a star must start with about 7 to 20 times the mass of the Sun before the supernova. Only stars with more than 20 times the mass of the Sun will become black holes. I hope you enjoyed this video, and thanks for watching.